Hello and welcome, everyone. This is a broadcast brought to you by the Digital Learning Network. We are excited to be presenting today. This weekend, we are going to be launching another rover that's going to travel on its way to Mars. And this webcast is to let you learn all about the mission. And we're going to have a lot of exciting things in this program. Where we are going to visit various NASA centers. We're going to go to where the launch is actually happening down in Florida at the Kennedy Space Center. We're going to go out to the West Coast at the Jet Propulsion Laboratory, where they built this rover that we're going to be talking so much about this afternoon. So, and let me begin with a hello and welcome from the NASA Marshall Space Flight Center. I'm located in North Alabama, and I'm your host kind of for today's program. So thank you. Also, to the webcast viewers out there, I want to let you know that we have two schools connected from Flint, Michigan, and we will be interacting with them. But in a moment, I'll give you a way that you can interact with our program, where we are going to let you send questions in should you see anything that you would like to have an answer for. So we'll give you an email in a moment. But again, today's program is all about the launching of the Curiosity rover. Today we're going to learn a little bit about Mars. I have just a short overview, a little bit of information about this red planet and why we're so excited to explore it. And as I mentioned earlier, we're going to go down to the Kennedy Space Center where the launch will be happening, and then out to the Jet Propulsion Laboratory. And then finally, at the end of the program, we will check in with some questions. As I mentioned earlier, we have two schools connected. I want to say Randall's Elementary and Rankin Elementary are the names of those schools. And again, they're located in Flint, Michigan. But again, we're also interacting with those of you watching on the web. We have a webcast that we're presenting this out to the whole world, I guess, in that case. And we want you to send us some questions, too. So we have a way to do that. We have an email address. Let me put this on the screen full here. If you were to send an email to nasalearn@gmail.com. These questions would come directly to my phone here, and I can try to answer them, or we can try to answer them at the end of the program. So any questions that you have, if you're watching on the web, the email address is nasalearn@gmail.com. One more time, nasalearn@gmail.com. So again, hello and welcome. Today's program is all about this new rover that we're going to launch on Saturday to the planet Mars called Curiosity. So I think the first thing that we probably should begin with is the planet Mars. Well, we call Mars, it has a nickname of the red planet. And I have a really neat video that I'll show you in a moment about why we call it the red planet. But some basic information about the planet. Well, how far away is it? It's approximately 140 million miles away. It's the fourth planet from the sun. And the reason why we're so interested in learning more about Mars is it's kind of similar to the Earth in many ways. And although its orbit is a little bit longer, because of its axis, Mars has seasons similar to the Earth. Also should point out, though, because Mars is a little bit farther away, the distance that it travels is a little bit longer, so its orbit around the sun takes a little bit longer, which impacts the seasons. So the seasons themselves are a little bit longer. Some more information about Mars. Well, the days are very similar to the days on the Earth. In fact, they're just a couple of minutes longer than an Earth day. And the temperatures are also the closest to the Earth when looking at the other planets. And the temperature variance there can get as cold as minus 125 degrees. But can get as hot as 37 degrees. So certainly of all the planets, it is probably the most likely that we could put up a space station or a Martian base there where we could live. And so again, if we're looking exploring out into the solar system beyond the moon, Mars is possibly one of those destinations where we might be able to make it work easier than other planets. But the red planet, why is it called the red planet? Well, I have a really neat video that explains this. This is from our website, nasa.gov, where we have all sorts of videos about Mars and the Curiosity mission. But this one is called, Why is Mars the Red Planet?
Is Mars really red? When you see Mars in the night sky, it definitely has a reddish tint to it. People have been noticing that for a long time. Even the ancient Egyptians called Mars the Red One. So where does that redness come from? Well, a lot of rocks on Mars are full of iron, and when they're exposed to the great outdoors, they oxidize and turn reddish, the same way an old bike left out in the yard gets all rusty. When rusty dust from those rocks gets kicked up in the atmosphere, it makes the Martian sky look pink. From a long way away, the whole planet looks kind of reddish, but if you get a close-up view, with an orbiter, lander, or rover, you'll see that a lot of Mars is actually more of a butterscotch color. Depending on what minerals are around, some landscapes can be more golden, brown, tan, or even a little greenish. So in fact, there are a lot of different colors on what we call the red planet.
So I thought that was a good explanation, and I thought I'd share that with you. Again, some of this oxidized dust goes up into the atmosphere, and when we look at it from far away, it appears red. But we talked about exploring Mars, and in the video also pointed out some of the different ways that we do this. I have just 3 quick descriptions of ways that we explore Mars. In the past, we have sent satellites on their way to other destinations, and they've simply flown by planets. And so we might classify this as a flyby. In fact, we have done a flyby of Mars. Another type of exploration that we would do with different planets, including Mars, would be where we would send a satellite there to orbit the planet. And as the satellite orbits the planet, it's going to take pictures and gather different sorts of information that we can learn to lose more about it. And then there is what we're going to send to Mars on Saturday, which is a rover. And this adds the complicated task of having to land on the planet and then release in a rover. Now, we have also sent other types of exploration robots out there, one of which is called a lander, and this is something that lands on the planet but doesn't move. But again, the mission that we are going to go through this weekend, that we're going to begin, the Curiosity mission, is going to use a rover. And later in the program, we're going to learn a little bit more about the specifics of this mission. But the big picture information, the headlines of this mission is we're going to launch to Mars this Saturday. Now, we're going to talk with Kennedy. We may have a delay at some point, so it could be, the date could be changed. But right now, we're planning to launch this Saturday at 10 a.m. Eastern Time. The trip to Mars takes about 8.5 months to make it from the Earth. And so we're launching Saturday, but the Curiosity rover will not make it to Mars until the beginning of next school year. And so what I'm going to do is I'm going to play a short video, and then we will come back and send it to the Kennedy Space Center. But first, here is a promotion, a video clip about our upcoming mission to Mars. And so there's a look at what the Curiosity rover will go through on its way to Mars and its landing. Just one final reminder to send questions in throughout the program. If you're watching on the webcast, you can do so at nasalearn@gmail.com. But let's continue on with the program. Let's go live to the Kennedy Space Center, where I'm told we have a special guest.
Thanks a lot, Scott. Damon Talley coming to you live from NASA's Kennedy Space Center. We're just across the Banana River Lagoon is Launch Complex 41, where we will be launching the Mars Science Laboratory on this Atlas V rocket behind us. We have a lot of special guests in the area for the launch coming. Now we'll be on Saturday at 10:02 a.m., Scott. Get that right, not 10 a.m., 10:02. We're very precise when we count backwards here. And my special guest today is all the way from the Jet Propulsion Laboratory. And in fact, Miss Bettina Pavry is here, and she works on the Mars Science Laboratory project. Bettina, tell us what you've been doing with this Mars Science Laboratory.
Well, thank you so much for having me here today. My role on the Mars Science Laboratory mission is the integration and test of the science instruments on the rover. And what that means is that we have many instruments on the rover which collect information that the scientists use to study the history of Mars, to understand how it was in the past and to understand how it is now. And those include cameras, those include chemistry experiments to understand what elements and minerals Mars is made of, to understand the environment. There's a weather station, there's an instrument that measures the natural radiation on Mars, and all of those things will help our science team understand how Mars is now and compare it to the Earth and understand its history.
And Scott, let us know if we get any questions come in. But one question I know we always get from kids is how long did it take to build this thing? And so maybe you could talk to that a little bit.
So this mission was first proposed almost 10 years ago. And it was intended as a follow-on to the two rovers that are currently on Mars. And so the Spirit and Opportunity rovers arrived on Mars in 2004 and have been operating there ever since. Only one of them is still operating. They were intended to operate for 90 days and have operated for over 7 years. So we're very excited about that, and we're looking forward to this rover being on Mars and helping to add to the knowledge that those rovers have collected for us.
And Bettina, one misconception students have is that we're going there, we're bringing some samples back, but that's not the case. How do we get this data back from this Mars Science Laboratory?
So the rover collects the information and stores it like files on your computer. And once it has stored enough information, all the information from a day's worth of activities, it talks to the Earth. And the way it talks to the Earth is over a radio. And it can talk to the Earth directly using what we call a high-gain antenna on the rover, or it can use satellites that are already in orbit around Mars to talk to Earth to relay the signal from the rover on the surface to the satellite around Mars and then to the Earth. So that gives us different ways to communicate with the rover so that we can ask it to do things on the surface, we can send it commands, and it can tell us how it's doing, if it's healthy, and what kind of science data it's collected. It can send us images, it can send us all of the analyses that have been collected by those science instruments on the rover.
And we were talking earlier, how long does it take for a signal to get from Mars back to the Earth?
So it varies depending on where Mars is in its orbit. So it can take up to 20 minutes one way for that signal to get from the Earth to Mars, or to send a signal the other way.
It's sometimes like my children, 20 minutes for that signal to sort of get through. But Bettina, tell us about what your role has been on this mission.
Yes, so earlier I was talking a little bit about the science instruments, and one of the things that we need to do is to work with the scientists who have very specific goals, what they want to accomplish, and we try to work with them to design a machine, an instrument that will accomplish what they want. So for example, if someone wants to build a camera, or they want to build an instrument that will tell us what kinds of minerals are in the rocks on Mars, we work with them to figure out how to build that. and then once that instrument is being designed, we figure out how we are going to put it on the rover. How big is it? How will we attach it to the rover so that it's secure, because the rover is going to be bouncing around a lot on its journey to Mars and also on Mars. We need to also provide power to it, electricity, so that it will operate successfully. And we need to make sure that when we operate all the instruments together, we have enough power. We need to be able to talk to it like you talk to your computers. You need to send commands to that science instrument, and you need to get data out of it. So we work with the scientists who want to collect this data, figure out how to design that instrument, get it on the rover, and have it work as part of the whole rover system. So my role has been to work with the science team in order to make sure that all their science instruments will operate as expected on the rover.
All right. Now, we were watching the animation earlier of launch and entry, and you had called the entry into the Martian atmosphere the 6 minutes of terror.
That's correct. Yes.
And that's because it, talk to that a little bit, why is it 6 minutes of terror?
Yes, so it takes 6 minutes from the time that the shell, the capsule that the rover is in, hits the atmosphere of Mars until it's on the surface. So it comes in very, very fast. It's coming in at about Mach 25, so it's the same, sort of a similar speed to the space shuttle being in orbit around Earth. And it takes, so the first thing that happens is the capsule goes through the atmosphere slows it down, but it's going so fast that it heats up the air around the capsule, and that helps to slow the capsule. And it makes it very, very hot, and the shell protects the rover. And then when it's slowed down enough, the bottom of the shell drops off, and there's a parachute to lower the rover towards the surface. And at the very end, we use rocket engines to slow the rover down and then lower to the surface off of a crane. So that whole process, end to end, takes about 6 minutes, and it's completely over by the time that the radio signals get back to us here on Earth. So the rover has to be smart enough to do that whole thing by itself, and we need to plan in advance so that we think about all the things that can go wrong and teach the rover how to deal with those things so that that whole process works smoothly.
Wow. And Bettina, we would like to know a little bit more about your background, and where did you go to school, and what did you major in, things like that?
So I went to college, and the first thing that I studied was physics. I got a degree in physics, and because I was very interested in astronomy and just science in general, and physics is kind of the basis of so many other sciences. And so for me, that was very interesting. And then I also went to another college and got an engineering degree because I was interested in building machines to explore the planets. And the next thing I did was I went to graduate school, and because I was very interested in geology. While I was studying physics and engineering, I took some geology classes, and I said, this is really interesting to me too. And it works together nicely for my current job because it helps me, the geology helps me to understand what the scientists want to accomplish on Mars. And at the same time, I can work with the engineers who are building the rover and building the science instruments and understand how they need to get their job done and what kind of information they need. So altogether, this background has helped me to do a better job working with the science instruments on the rover.
Speaking of backgrounds, I would like for you now to focus your attention on the background here. We're going to show you a launch video of the Juno spacecraft, which actually went out to Jupiter earlier this year. It's the same type of rocket, though, that we're using to launch the Mars Science Laboratory on. So we've got 6 minutes of terror, an 8.5-month cruise stage, 40 minutes of activity near the Earth, and we're going to show you about the first 2 minutes of that. Now, this is not the Mars Science Laboratory, but this is hopefully the scene that we will have Saturday at 10:02 a.m. So let's go ahead and roll that.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff of the Atlas V with Juno on a trek to Jupiter, a planetary piece of the puzzle on the beginning of our solar system.
So this is so-called Atlas 541. The 5 is a 5-meter diameter payload fairing. The 4 are 4 strap-on solid rocket boosters at the bottom. And the 1 is a single core stage, which is actually a highly refined kerosene and liquid oxygen.
Mach 1.
And so we can sort of listen in to some of the telemetry, the data coming back from launch control here.
Max Q. Boosters throttling up.
We heard the max Q. That's something we're used to with shuttle. That's the maximum pressure. And that happens at a certain point based on the speed and the density of the atmosphere. Now those solid rocket boosters on the bottom are about 65 feet high. And each one produces about 330,000 pounds of thrust. Add all that together, that is over 1 million pounds of thrust. The core stage of the Atlas booster develops about 850,000 pounds of thrust. So you've got roughly 2 million pounds of thrust, and the weight of the spacecraft, or the rocket and the spacecraft at liftoff, is just over 1 million pounds. So you've got a net force of 1 million pounds up, which causes it to accelerate. And at about 30 miles high, I believe we're going to lose the solid rocket boosters will attach. There they go.
1, 2, 3, 4, and 5 jettison. Visual indication that all solids are separated.
And once again, that's at about 30 miles high. Now, at that point, we start to sort of lose what's happening with the ground-based camera on us. Let me bring us back here. My apologies. And so we're going to come back to the studio now. And so then it will separate again. There's a second stage of a Centaur that will ignite another engine, and that will burn. And then essentially, once that's done burning, it will be on an 8.5-month cruise phase to Mars. So what happens during the cruise phase with the spacecraft?
So during the cruise to Mars, we're checking out all of the systems that we'll need to land on Mars, and also all of the science instruments that we plan to operate on the surface of Mars. So we want to make sure that everything survived the launch, because the launch puts a lot of stresses on all of the parts of the rover. So it gets a lot of shaking. They get pushed very hard because the rocket is accelerating much faster than gravity. So it's all of these things can't put a lot of stress on all of the systems in the rover. We want to check them out fully such that when we get to Mars, we're ready to go.
And so the monitoring of the systems is all going to happen at JPL.
That's correct.
Speaking of JPL, it's time to throw it to my good buddy Lyle Tavernier out at JPL. Lyle, are you there?
I'm here. Good afternoon, everybody. Like Damon said, my name is Lyle Tavernier, and I am speaking with you from the NASA Jet Propulsion Laboratory in Pasadena, California. Now, we do have a lot of really interesting stuff to talk about concerning Curiosity, but before we do that, I have a special guest here. His name is Paulo Yance, and Paulo Yance is a robotics engineer, and he's currently working on a Mars sample return instrument, and the sample return instrument is hopefully one day going to be used to actually bring samples back from Mars to the Earth for studying. Let's see if we can get Paulo in here. Hi, Paulo. It is good to see you, and thank you for coming. How are you today?
Good. I'm doing good.
Great. Well, let's get started with some questions. As the students have heard, we've been to Mars multiple times in the past. We've done flybys, and we've had landers, the Viking lander, Phoenix lander, and 3 rovers. Why are we returning to Mars again?
We're returning back to Mars because we want to now study if Mars was habitable to life, either now or in the past.
Now, what information on Mars do we hope to discover with Curiosity that will tell us that?
We're actually going to be doing a lot of looking for certain minerals and chemicals that are basic building blocks for life. Some of these include carbon materials, oxygen, hydrogen, nitrogen. And we have a whole bunch of instruments that are going to be able to help us with this search, including some some tools on the end of the arm that could drill into rocks to gather samples from inside rocks, and a whole suite of instruments on the rover itself that are going to be able to analyze the chemical compositions and the minerals inside these rocks to try and find these organic materials and these materials that could show that life could or could have existed in the past.
Great. Now, we've seen some videos, and what makes Curiosity different from other rovers and other landers?
All right, the most obvious thing is that MSL is going to be huge. It's going to be huge compared to the last rovers and the last landers that we've landed on Mars. MSL is going to be approximately 2,000 pounds and about the size of a small car. And with it, we're going to be able to drive further, go over more rocky terrain, as well as carry a lot more equipment and a lot more instruments with us.
Interesting. Now, what has been your favorite part about working on Curiosity?
The favorite part I love about working on the Mars rovers is having the chance to really, the challenge of building something to survive on Mars, as well as using all the training and all the things that I've learned in school and college to be able to do this. And then on top of that, being able to work with some of the brightest and smartest people from around the world.
Now, this might be hard to narrow down, but what would you say is the most important thing we're doing on this mission?
One of the most important things that we're doing with Mars Science Laboratory is this is the first time we're landing something this big on the surface of Mars. It's much bigger than any other landers and the rovers that we've landed in the past. And to do so, we're going to have to use a bunch of different techniques, including using a spacecraft with a heat shield, using a descent stage, which is like a jetpack on top of the rover, and then using what we call a sky crane, which is basically lowering the rover to the surface of the Martian planet using a giant cable. And if we can pull this off, it's going to be something that we can use in the future to land more sophisticated instruments, more sophisticated landers and rovers on the surface of Mars, including some of the missions which we want to try and run in the future to collect samples from Mars and bring them back to Earth.
Great. Now, we have a lot of students joining us today, so if you're a student today and you want to one day be a NASA scientist or engineer and work on missions like Curiosity or new missions that haven't even been dreamed up yet, what are some things that you might want to do?
Well, I got to say, we definitely need a lot of smart, intelligent, hardworking, and creative folks to work with us in the future to design the next new Mars missions. And all of you have the opportunity to do that in the future. Just make sure you do well in school, study hard, go to college, and get involved in as many science and technology and robotics projects, either through your school or on your own as you can, to get some experience.
Paulo, thank you so much for joining us today. We really appreciate it.
Thanks a lot.
All right, well, boys and girls, you just heard from Paulo Yance, and he is a robotics engineer here at the Jet Propulsion Laboratory. And what we're going to do now is talk about Curiosity. And I'm going to show you a picture of Curiosity. And this right here is what an artist believes it would look like when Curiosity is actually on Mars. And Curiosity is a mobile robot used for investigating Mars' past or present ability to sustain life. And this this is not the first time we have sent a rover to Mars. As was mentioned earlier, we've sent we've sent rovers to Mars previously. We started off with a very small rover. Actually, it was called Sojourner. It only weighed 23 pounds, and it was about the size of a microwave. What you see here is a wheel from Sojourner. And with the things that we learned from Sojourner and the success that we had, we found ways to develop larger rovers, and this is a wheel from Spirit and Opportunity, the Mars exploration rovers. These were bigger. They were 400 pounds, and they were about the size of a golf cart. Now what I want to show you next is a wheel from Curiosity, and you can see that it is much bigger. And the reason it is much bigger is because, as was mentioned by Paulo, the rover is much larger. And it's about the size of a small SUV. And I'm going to show you a picture of all three of these rovers together here. This is what we call the rover family portrait. And you can see that Sojourner right there in the middle is quite small, especially when you look at Curiosity next to it. In fact, Curiosity's wheels are about the size of Sojourner itself. Now, what we've got here is a map of Mars, and what we have here is all of the different landing sites that we've had. We have Phoenix, the Viking landers, Pathfinder, Spirit, and Opportunity. And in that orange box, what you can see is the landing site for Curiosity. And Curiosity is going to be landing at a place called Gale Crater. And scientists have wanted to go to Gale Crater for a very long time. But in the past, it was too dangerous. We didn't have the technology, but with the things that we've learned and the technologies we've developed, we're now actually able to land inside of a crater. Now I want to show you a picture of Gale Crater, which is actually named for Walter Gale, who was an astronomer who observed Mars back in the 1800s. And if you take a look at Gale Crater, this is a picture. It's 96 miles wide. It's very big. It has many layers of rocks for Curiosity to explore. And scientists are really excited about that because if you look at the lower layers of rock, you can see the rocks that are very, very old. And as you move up in the layers, you're getting newer and newer layers of rock. And you can see the history of rock and mineral formations within Mars itself. And so they're really excited. Now, as Bettina mentioned, there are many, many science instruments on the rover. And if you take a look here, you can see the scientists here working on just some of them. This is the robotic arm that Paulo had mentioned, and there are quite a few instruments on there that we'll talk a little bit about. And this image right here gives you an idea of just how complex this rover is. All of these are different science instruments, and we've got cameras, and we have radiation detectors, we have weather tools, we have all sorts of different science instruments on here. And because we have so many science instruments on there, we really had to make the rover much larger than it was in the past. Now, among the different tools that Curiosity has are 17 different cameras. And if you think about it, 17 cameras is a lot. 12 of them are for engineering purposes. And then we have 2 that are called mast cams, and I'll show you a little bit about those in just a moment. We have one called the Molly and the Marty cam, and we have a chem cam. We also have a laser that we'll talk about in a little bit, and we have several tools that will help us collect some samples. Now I mentioned the mast cam, and the mast cam right here are 2 cameras on the part of the rover that stands up when you see a complete picture of the rover. This is the part that's standing up. And these are capable of taking HD videos, so we'll get some really nice videos back from Mars. And it's also able to take photographs in stereo. And that's going to give us some of those really nice 3D images of Mars that we have. And scientists will use these cameras to take pictures of the area around Curiosity and figure out what they want to study and what they want to go look at in closer detail. So these cameras are really important for Curiosity and for the scientists and engineers here on Earth to figure out what they want to take a look at. They also built the laser, and if you look at the top, it has a special tool called a spectrometer, and what happens is this shoots bursts of lasers at rocks, and it can actually find a rock and shoot a laser from about 10 meters or around 30 feet, and the laser can detect what types of minerals and what sorts of elements are inside of that rock, and will allow scientists to get a better understanding of what the rocks on Mars are made of and what sorts of materials are in those rocks. I've got an interesting picture right here of what that would look like in action. You don't actually get to see the laser beam, but the artist put it in here so that you can see what it looks like, and it's able to read the rock dust and plasma to tell us what the rock is made of. Now I mentioned that there were also some weather instruments, and if you look here very closely in those yellow boxes, there are 2 little booms on the rover's mast or neck, and they're called REMs, and they're monitoring temperature on Mars, they're measuring the wind speed on Mars, and they're also measuring the direction of the wind on Mars. They really want to get an understanding of what the climate and what the weather is like on Mars. Now, as Paulo mentioned, there's also that very long arm, and I've got a model of Curiosity right here, and the arm extends right out from inside, and at the end of the arm we've got quite a few tools on here. There are tools to detect chemical elements. There are tools that can detect minerals, including some of those that are found in water. And we've got an instrument on here that detects organic materials, like what Paulo was talking about, the things we hope to find on Mars with Curiosity. It also rotates. It's a little bit difficult to see with this camera, but you can see that it rotates to allow different tools. There's a drill on there that will allow scientists to collect samples of rocks as well. One of the items on that end that I find very interesting is a hand lens. It's like a magnifying glass for studying soil grains. And in fact, it's a very powerful one. It can view rocks and hopefully maybe even ice crystals, if there are any, down to the size of a human hair. Now, I don't have a lens quite as powerful, but I do want to just give you a quick demonstration of things that it might look for. I have a few different samples here, and I'm going to get really close into these, a little bit closer than I could probably get with my eyes. And I'm going to just talk about these two different samples, and you can see they are quite different. Over here we have these samples right here, and you can see not only are they different in shape and size, but they're also different in color. We've got some very small samples here, and these different parts, when you're looking at them under the camera, can tell you a lot about the composition of the soil and if it's something that you want to study further. So we've got two samples. These are actually simulated soils. This is one that scientists believe is similar to what is found on Mars, and we've brought rocks back from the moon. This is not actually moon dust, but this is a simulant of what the dust on the moon looks like. And so this is just to give you an idea of what some of the things that handheld lens or that Mollycam might be looking for. Now, because Curiosity is so big and it's packed with so many instruments, we really had to put in, we had to make things much, much larger. The rover is larger itself, but not only that, but the capsule that holds the rover is much larger, and the parachute that's going to slow it down is a very large parachute. If you look in the picture here, you can see in the two corners, those are two people that are standing up next to that parachute, and they were testing that parachute out at the NASA Ames Research Center. It's just an absolutely huge parachute. And what's going to happen, and actually this has already happened, the rover is packed inside of this protective shell. We have a cruise stage on top, and that cruise stage is what's going to help it on its way to Mars to make sure it's on course and on track. The back shell is a protective cover. There's a descent stage, which you saw in that video, that helps lower it down to the surface. There's the rover itself. It's got its wheels folded up in there. And then there's the heat shell. And the heat shield is what protects it from the high temperatures that it encounters going into the atmosphere, because it does go in so fast that the friction from the air will create a lot of heat, and we want to be able to protect that rover inside of that capsule. Now, Damon had mentioned, and we saw the video of the Atlas V being launched, and this is where it all comes together. These are all the different parts, and the Atlas V is 191 feet tall. It is about as tall as a 19-story building, and all the way at the top, you can see in this circle right there, is Curiosity. Now, Curiosity is packaged in there so that it can make a safe trip to Mars, and it's actually put in there upside down. It's doesn't feel that it's upside down, of course, because it's a robotic rover, but normally we think of the rover as having the top on top and the wheels on the bottom, but it's put in there upside down for launch. Now, as was mentioned before, once the rover is on Mars, it's going to have to communicate with Earth. And Bettina mentioned the high gain antenna. There's an antenna right here that can send information either back to the Earth, or it can send information to satellites that are in orbit around Mars. And we have a couple of satellites that are in orbit around Mars right now. And the Mars Reconnaissance Orbiter and the Mars Odyssey Orbiter are both satellites that will be able to send information back to Earth. Now, those satellites, when they send information back to Earth, they're actually sending information to what's called the Deep Space Network. And the Deep Space Network are 3 very large communication antennas. They're huge. They're about 70 meters across, which is nearly the size of a football field. And there's one in California, one in Spain, and one in Australia. And they do that so that we are able to communicate with the satellites no matter what part of the Earth is facing Mars. And you know, boys and girls, I got a chance to visit the Deep Space Network earlier this year, and they really are huge. When you're standing by them, all you can really do is look up because they are so big. Now, we did take a look at those, and Bettina mentioned that it can take 20 minutes sometimes to have these rovers communicate with the Earth. When they're close, and let me show you that right here, the signal can take about 5 minutes to get to Earth. However, when Mars is on the opposite side, it can take up to 20 minutes. Now that means that we send a signal to Mars and it takes 20 minutes to get there, and the rover lets us know that it's received the signal, and it takes another 20 minutes for that to get back. So that can be up to 40 minutes to communicate with the rover. And because of that, when the rover is on Mars, we don't have a joystick that we use to drive it around, because that would take too long. We would have to push it forward and wait maybe 30 or 40 minutes to find out if it moved correctly. So what we do is we have a list of commands for that rover. We send the commands, and the rover will automatically do all of those commands that we send it, that we send out to the command. And depending on the day and depending on what has happened in the past and what it's found out, Curiosity could have a very different schedule. It depends on what she finds. She might take pictures. We might have her just driving to a new place one day. She could be using her drill to determine the composition of a rock, and she might be using her laser on the next day. And Curiosity is expected to work for about 1 Martian year. That's about 2 Earth years. And launch, as we mentioned already, was scheduled for 10:02 on Saturday morning. Now, if you are on the West Coast like me, you do have to get up very early to watch that because it's going to be at 7:02 in the morning. However, you can watch it on NASA TV if you're not fortunate enough to be at the launch site on that day. Now, we are going to turn it over for some questions. We've got a little bit of time. And let's see. I'm going to see, Scott, are you able to unmute Randall's or Reagan Elementary's microphone so we can maybe hear if there are any questions? And Randall's and Reagan Elementary, if you would please have maybe somebody able to monitor and ask the questions for us.
And this is Scott. Lyle, we have 2 schools, Rankin and Randall's. Why don't we start with Rankin and have them ask a couple of questions, and then we'll try Randall's. And also, we do have some questions from the web, which we can ask after we've done that. And just on a programming note, the schools have to be released at 5 till. So we'll try to answer their questions and then go more to the web questions.
Okay, great. So let's start with Rankin Elementary, you said?
Yeah. All right. Let's start off with Kennedy. What question do you have?
What kind of new technology does the rover use?
Okay, what kind of new technology does the rover use? Is what Kennedy said. Did you get that, Scott?
Yeah, I'll take that answer. One of the new technologies that we're really excited about is the sky crane, and the sky crane is it's going to drop out of the the heat shield and the back shell, and it has those thrusters that will lower it slowly down to the surface. And that is something that we're excited about because in the past we've used airbags to drop rovers onto the surface, and with a rover as large as Curiosity, we really can't drop it with an airbag. And so what we need to do is we need to have this new technology, this sky crane, that will gently lower it down. And if we're able to successfully do that, we will have found a new way that we can bring other large and heavy items to other planets.
Okay, thank you. Brad, did you have a question?
What makes the rover work?
What makes the rover work? Do you mean like batteries or power?
Hey,
What makes the...
I think Kennedy Space Center will take this when we were talking about this a little bit earlier. And Bettina, what's the power source on this thing?
So the rover uses a nuclear power source, and the way it works is it has some nuclear material that generates heat, and it takes the heat and uses that to make electricity. And the reason that we're using this power source is that the previous rovers, the Spirit and Opportunity rovers, had solar panels, and that meant during the winter they often did not have enough power to operate all the time. So the scientists for this mission wanted a rover that could operate at night or during the winter. And so we're hoping that the Mars Science Laboratory, Curiosity, will be able to operate throughout the year using this new power source.
By the way, I wanted to be sure that you guys saw the laser beam in action. So take a look here. This is the Mars Science Laboratory about to do its thing with a laser beam. Check this out. He's going to get one more rock here.
And maybe we'll get more question from Rankin and then go to Randall's elementary school so we can get a question or two from them as well.
Okay, Caitlin, what's your question?
What type of water formations would Curiosity might be looking for?
What type of water formations might Curiosity be looking for? Okay.
Be happy to take that one here at Kennedy, and so Ms. Bettina?
Yes, so actually on the surface of Mars, there's no liquid water anymore. We have only ice on the surface of Mars. And the reason for that is that there's very little air on Mars, and so liquid water would boil off right away. So it's very cold, so there's ice. And but in the past, there was water on the surface of Mars, and we can tell that because of the minerals, the types of minerals that we found on Mars, and the kinds of rock formations. And we can see that there are old river channels on the surface of Mars that were carved by running water. So this is very interesting. Mars used to be a lot more like the Earth, and now it's different. And geologists really want to understand how that happened. So that's part of the mystery that we're trying to solve.
Thank you very much. Off to Randall's.
Okay, Morgan, what was your question? Nice and loud.
Why don't you just modify the solar panel to make it run better, like during the winter?
Were you able to hear a question?
Yeah, I was able to hear that, and I'll go ahead and answer that. One of the things that they were finding is even with solar panels that were able to work well, they found that a lot of dust was settling on the solar panels. And when the dust from the Martian atmosphere settles on the solar panel, even with the best solar panels, we weren't able to get enough light onto the solar panels. And so that's why we wanted to find something that would give us a continuous source of power. Excellent question.
Caleb, what was your question?
I was, does it rest?
Hmm?
Does it rest?
Does it rest? The robot?
Could you repeat that question a little bit louder, or
have to take breaks so it doesn't overheat? Like some mechanical things we have here have to have kind of like their timed like cool down periods.
No, I think we were talking about sort of the heat generated by the batteries, and sometimes you were talking about that earlier. You wanted to talk a bit more about that?
Yes, so the power source for MSL also produces heat to keep the rover warm during the night and over the winter. So it is used for both the purposes of providing electricity and also heat, so it's a very good solution for this rover.
Jada.
Why is the satellite so big? Oh, why is the rover so big?
Were you able to hear? Why does the rover need to be so large to be sent up there?
We can talk to that one too. Why is that rover so big, Bettina?
So a little bit earlier, Lyle was talking about all of the science instruments that we were putting on the rover so that the scientists could help try to understand the history of Mars and the way it is now. And to have a place to put all of those science instruments and carry them and get them over the kinds of rough terrain that we're going to find on Mars, we needed a much larger rover. So this gives us a lot more capabilities, more cameras, more science experiments, so that we get a lot more information out of this mission than we did out of the previous one. So the scientists are going to be very excited with all the data coming back from Mars.
And just to add on to that, if you can see this visual, you can see that the older rovers, the Mars exploration rovers, only had 11 pounds of science instruments, where Curiosity has 165 pounds of science instruments. And because there are so many, that's why we needed to make it that much larger.
One more from Randall's. Megan.
What happens to the pieces from the rocket? Or the rover?
I'll take that one here. Growing up in the area myself, seeing a lot of launches, so the question is, what happens to the pieces of the rockets as they come off? That's one of the reasons we launch on the east coast of the United States, is so that these stages of the rockets could fall into the ocean. They're not landing on populated areas. And some, for instance, on the space shuttle would be recovered, but for these expendable launch vehicles, these ELVs we call them, they're called expendable, we don't recover them. And so they will fall harmlessly into the ocean. We do warn local mariners of a possible impact zone, and in fact there have been occasions when a boat has accidentally gone into the potential impact zone that has actually stopped a launch. So that is one of the parameters at launch, is make sure no recreational boats or no other boats are in the area where one of these could possibly land. And so they hit the ocean harmlessly, and they are not recovered. But some things in the past have been recovered. We got a spacecraft, Mercury spacecraft, way back in the 1960s. It actually sank. We didn't go back and get it until about 40 years later. We fished it out of the bottom of the ocean, and it's now on display in Kansas. So in general, those things are not recovered.
And Lyle, this is Scott at the Marshall Space Flight Center. I wanted to check in with some of the web questions that have been coming in. We've gotten quite a bit more so than I expected. We've got close to 30 or 40, so I will tell you we're not going to go through them all, but let me just try to hit a couple of them. One question was, how long will the rover be on Mars? And the short answer is, if it makes it to Mars, it will be there forever. It's not going to come back, so it will be on Mars forever. Let's see, another question asked about the top speed of the rover. How many miles per hour will it travel? And I think you're thinking way too fast. This thing will at best travel 300 feet per hour. So it's not going to do miles. It's actually going to do feet. And in most of the cases, when it's traveling, it's going to be going 1/3 slower. Let's see. Let me find one more, and we'll throw it back to Lyle, who can close out our program. Let's see. Here's one with from. Okay, that was Austin. I already clicked on that one. I'm sorry. One more question. We talked about fuel being a nuclear fuel, and how long did it take to build the rover? And I guess we're probably, maybe at this question, we already answered that we started planning a long time ago, but once we had the plans, how long did it take to build the rover? And we'll throw it out to Lyle to close out the show at the Jet Propulsion Laboratory.
Thanks, Scott. The rover has actually been being worked on for, I believe, 4 years now. It actually could be 5 years. It's been under construction for quite a while now. And once they finished putting it all together in back in June, they wrapped it up and they sent it off to Florida. And what I want to do is, to close things out today, is I want to show a real short video of them packing up the rover before they ship it off to Florida, and then we'll do a narrated launch that gives a little bit more detail. But I do want to thank everybody for joining us today, and we hope you really enjoyed our program. And I'm going to end it right here with this Packing for Florida video, followed by the narrated launch overview. Here we go.
Before Curiosity can explore Mars, it's got to get there first. The last stage of the launch vehicle gives the spacecraft a final push and spins it up for our 8.5-month cruise to the Red Planet. Ten minutes before hitting the atmosphere, the cruise stage separates and final preparations for entry begin. Hitting the atmosphere at about 13,000 miles per hour, the spacecraft begins to slow down. While slowing down, the spacecraft uses its thrusters to help steer toward the landing target. We throw off weights to rebalance the spacecraft so that it's lined up for parachute deploy. After slowing to about Mach 2, or about 1,000 miles per hour, we deploy the parachute to slow down even further. Once we're below the speed of sound, the heat shield separates and the spacecraft looks for the ground with the landing radar. Once we reach an altitude of about 1 mile, the spacecraft drops out of the back shell at about 200 miles an hour. It then fires up the landing engines to slow it down even further. Once we've descended to about 60 feet above the ground and are going only about 2 miles per hour, the rover separates from the descent stage. As the rover is lowered, the wheels deploy in preparation for landing. The ground and touchdown has been detected. The descent stage cuts the rover loose. It flies away, leaving Curiosity safe on the surface of Mars. One of the first things Curiosity does after landing is to deploy the mast, which supports many cameras and instruments. Curiosity shoots a laser at an interesting target. This helps us quickly understand the kind and composition of that target from a distance of up to 30 feet. If the target's worth a closer look, Curiosity can drive up and inspect it with the instruments and tools at the end of its arm. The drill on the arm allows us to grab some of that rock and deliver it to the laboratory instruments inside the body of the rover. Those instruments can tell us even more about the mineral composition, getting us closer to understanding whether life could have existed on Mars. Curiosity will be exploring the red planet for at least 2 Earth years, and there's no telling what we will discover.